Tonight, as the world settles into darkness and distant city lights soften into small glowing islands against the night, we will spend some time together with one of the strangest ideas humanity has ever discovered. There is no need to hurry. There is nowhere to be. The universe has already been waiting for billions of years. It can wait a little longer. Perhaps you are listening beneath a blanket while rain taps gently against a window. Perhaps the room around you has become quiet except for the low hum of distant machinery, the soft movement of air, or the almost imperceptible rhythm of your own breathing. Whatever brought you here, welcome. Tonight, we will wander through quantum mechanics, not as students preparing for an examination, not as scientists racing toward equations, but as travelers moving slowly through a landscape of ideas. A landscape where particles behave like waves, where certainty becomes difficult to hold, where emptiness is not truly empty, where reality itself seems softer around the edges than our everyday experience suggests. Far above us, stars continue their ancient journeys through the darkness. Far below us, beneath continents and oceans, atoms vibrate quietly inside stone. And within every object around you, from the fabric resting against your skin to the air drifting gently through the room, quantum events unfold endlessly. Invisible, silent, patient. Long before modern science, human beings looked upward and wondered what reality was made of. They imagined tiny, indivisible pieces of matter. They imagined hidden structures beneath appearances. They imagined worlds concealed inside worlds. Tonight, we will follow those questions into a realm so small that ordinary intuition begins to dissolve. And as we do, there is no need to remember everything. You may simply listen. You may allow ideas to drift past like clouds crossing a moonlit sky. You may even fall asleep. The universe will continue its quiet work regardless. And perhaps there is something comforting in that. Our story begins with a simple observation. Everything around you appears solid. The walls, the floor, the bed, the furniture, your own hands. Yet beneath that appearance lies an astonishing truth. Atoms are mostly empty space. If an atom were expanded until its nucleus sat at the center of a vast cathedral, its electrons would drift far away near the outer walls, leaving an enormous region between them. Matter feels solid, not because it is packed solidly together, but because quantum rules prevent certain forms of overlap. The solidity of the world emerges from invisible relationships, from patterns, from probabilities, from fields. In a strange way, reality resembles a melody more than a machine, not a collection of separate pieces, but an arrangement of interactions. And perhaps that is our first quiet lesson of the night. Things are not always what they seem from a distance. Sometimes the deepest truths are hidden inside ordinary experiences. Sometimes vast mysteries rest beneath familiar surfaces. And sometimes an apparently solid world is mostly made of emptiness. In the silence of deep space, far from planets and stars, another strange idea waits for us. A quantum particle does not always behave like a tiny object. Sometimes it behaves like a wave. This discovery emerged gradually through centuries of observation. Scientists found that light, which had often been described as a wave, could also behave like a particle. Later, they discovered something even stranger. Electrons, which seemed to be particles, could also behave like waves. Imagine moonlight spreading across a calm ocean. Ripples overlap, patterns emerge, peaks combine, valleys cancel. Waves possess a fluid elegance. They spread naturally through space. Particles seem different. Particles appear local, specific, contained. Yet quantum objects somehow display qualities of both, not because they switch between two separate identities, but because reality itself operates according to principles more subtle than ordinary language can easily describe. Elsewhere in the universe, beyond distant nebulae and drifting clouds of cosmic dust, countless atoms participate in this strange dance. Stars shine because quantum processes unfold within their cores. Every ray of sunlight that has ever touched Earth carries evidence of these invisible rules. The warmth of morning, the growth of forests, the movement of weather, the existence of life, all emerge from a universe whose deepest layers are far stranger than they first appear. And perhaps there is comfort in knowing that mystery is not a flaw in reality. It is part of reality. A mountain remains beautiful even when we do not know every stone. The ocean remains magnificent even when its deepest trenches remain unseen. The universe remains worthy of wonder even when certainty fades. Now let us drift toward one of the most famous ideas in quantum mechanics: probability. In everyday life, we expect objects to possess definite locations. A book sits on a table. A leaf rests on the ground. A ship crosses the sea. But quantum particles exist within a more uncertain framework. Before measurement, their behavior is often described through probabilities rather than definite outcomes. This does not merely reflect ignorance. It reflects something deeper. A quantum wave function describes possibilities, not certainties, potential paths, potential positions, potential futures. Imagine standing beside a fog-covered coastline before dawn. The landscape exists. The cliffs exist. The sea exists. Yet much remains hidden beneath mist. Quantum probability is not exactly like fog, but the image captures something important. Reality contains possibilities that have not yet resolved into specific outcomes. The future remains open. The universe carries options within itself. Far beneath the ocean surface, where sunlight disappears and darkness becomes complete, strange creatures drift through black water. Many have evolved delicate ways of sensing their surroundings. Tiny signals, subtle changes, small probabilities. Life itself often survives through uncertainty. Perhaps quantum mechanics reminds us that uncertainty is not always an enemy. Sometimes uncertainty is woven into existence itself. Sometimes possibility is more fundamental than certainty. Sometimes the future remains beautifully unwritten. And so we continue, slowly, quietly, deeper into the quantum night. There we encounter another remarkable phenomenon: quantum tunneling. According to classical physics, Certain barriers should be impossible to cross without sufficient energy. A ball cannot simply roll through a hill. A traveler cannot casually walk through a mountain. Yet quantum particles occasionally appear on the far side of barriers that classical reasoning would forbid. Not because they break the laws of nature, because they obey deeper laws. The mathematics allows small probabilities for seemingly impossible journeys, and occasionally those possibilities become reality. Inside stars, quantum tunneling helps make fusion possible. Without it, many stars would shine differently. Perhaps life itself would never have emerged. Every living creature owes something to particles performing improbable journeys in stellar interiors billions of years ago. In a quiet sense, existence is built partly upon unlikely events, upon small chances realized, upon possibilities fulfilled. The night sky itself is evidence of that truth. Each star represents matter gathered from ancient clouds. Each planet represents a particular path through cosmic history. Each human life represents an unbroken chain of events stretching back through unimaginable time. And here you are, listening, breathing, existing within a universe that permits extraordinary things to happen. The room around you grows quieter. The darkness grows softer. Thoughts begin to slow. Outside, clouds may drift across distant stars. Inside, atoms continue their silent motion. And quantum mechanics continues everywhere. Not only in laboratories, not only in equations, but within every drop of water, every grain of sand, every pulse of starlight crossing the vast distances between galaxies. The universe is not merely stranger than we once imagined. It is stranger in gentle ways, patient ways, beautiful ways, ways that reveal themselves only when we move slowly enough to notice them. And tonight, there is no reason to move quickly at all. The deeper physicists explored the quantum world. The more they discovered that observation itself seemed to occupy a curious place within the story. This idea is often described in ways that sound more mysterious than they truly are. Yet, even the careful scientific version remains wonderfully strange. When physicists measure a quantum system, they do not simply peek at a tiny object already carrying all its answers. Instead, the act of measurement becomes part of the unfolding event. The wave of possibilities appears to settle into a particular outcome, a position, a momentum, a detectable result. Exactly why this transition appears as it does remains one of the great philosophical questions surrounding quantum mechanics. Even after generations of brilliant minds have examined it, the mystery has not entirely disappeared. Perhaps that is fitting. Some questions seem content to remain partially hidden, like distant islands obscured by sea fog, like mountains glimpsed only in moonlight, like ancient ruins slowly reclaimed by forests. Long before telescopes revealed distant galaxies, human beings often imagined the universe as something stable and predictable, a grand clockwork mechanism, an orderly machine, a place where every future event could, in principle, be calculated exactly. Quantum mechanics introduced a quieter possibility. Perhaps reality possesses an irreducible softness, not chaos, not disorder, but openness, a subtle flexibility at the foundations of existence. And if that is true, then certainty may never have been the deepest truth of the cosmos. Perhaps possibility was there first. In the silence of deep space, between stars separated by distances so vast that light requires years to cross them, particles continue to obey quantum laws. They do so without audiences, without observers, without applause. The universe performs its strange calculations quietly, as it always has, as it likely always will. And there is something deeply peaceful about that. The cosmos does not rush. It does not panic. It does not become impatient. It unfolds slowly, patiently, moment by moment. Another concept waits for us now, one that has puzzled generations of students and scientists alike: quantum superposition. At first hearing, the word sounds complicated, but the underlying idea can be approached gently. A quantum system can exist in a combination of multiple possibilities before measurement, not merely one hidden state waiting to be revealed, but a richer description involving many potential outcomes simultaneously. The mathematics captures this beautifully, yet language struggles. Human language evolved to describe forests, rivers, animals, weather, and daily experience. It was not designed for the microscopic architecture of reality, and so we often borrow metaphors. Imagine a distant coastline viewed through thick morning mist. Many paths run through the landscape, yet none stands out clearly. The entire collection of possibilities contributes to the scene before you. Only later does a particular route emerge. Superposition is not exactly like this. No metaphor ever fully succeeds. Yet such images can gently guide intuition toward the strange territory quantum physics inhabits. Far beneath Antarctic ice, ancient water remains trapped in darkness. Far beneath desert sands, forgotten fossils rest where vanished oceans once moved. Reality often contains layers hidden beneath immediate perception. Quantum mechanics reminds us that even certainty itself may possess hidden depths. And perhaps human life contains similar qualities. Many futures often lie before us. Many possible conversations, many possible choices, many roads not yet taken. The future exists as a landscape of possibilities until events gradually narrow the path. Quantum mechanics does not directly describe human decisions, yet the image remains comforting. Possibility belongs to the structure of existence, not merely to imagination. Elsewhere in the universe, stars are being born. Cold clouds of gas drift through darkness. Gravity gathers them slowly. Over immense spans of time, pressure increases. Temperatures rise. Nuclear fusion ignites. Light enters regions that were previously dark. These stellar nurseries often appear serene in telescope images. Great curtains of glowing gas, columns of cosmic dust, silent formations stretching across distances beyond ordinary comprehension. Yet deep within those clouds, countless quantum events occur every second. The largest structures in existence depend upon some of the smallest. The grandest cosmic architecture rests upon invisible foundations. And perhaps there is a lesson there. The world often changes through tiny processes repeated over vast stretches of time. Mountains rise grain by grain. Forests grow leaf by leaf. Civilizations emerge generation by generation. Stars shine through countless quantum interactions. Great things are often built from small things, quietly, patiently, without spectacle. Now we drift toward one of the most famous thought experiments ever created. The tale of a cat, not a real cat, a hypothetical cat, an imaginary participant in a scientific puzzle. The thought experiment was proposed by the physicist Erwin Schrödinger. Its purpose was not to suggest that actual cats exist in bizarre states of life and death. Instead, it highlighted difficult questions about how quantum descriptions connect to everyday reality. The scenario became famous because it transforms abstract mathematics into an image people can remember. A box, a hidden mechanism, a cat, an uncertain outcome. The details are less important than the deeper point. Where exactly does the boundary lie between quantum possibilities and ordinary experience? Physicists continue debating aspects of that question today. Different interpretations offer different perspectives. Some focus on measurement. Others emphasize decoherence. Others propose multiple branches of reality. Each interpretation seeks to explain the same successful mathematical framework. Yet, they tell somewhat different stories about what reality might ultimately be. Imagine standing beneath a clear night sky far from city lights. Thousands of stars become visible, perhaps tens of thousands. The sky appears simple from a distance, yet every point of light carries its own story, its own history, its own complexities. Quantum interpretations resemble those stars, different lights illuminating the same darkness, different perspectives on the same profound mystery. And perhaps not every mystery requires immediate resolution. Sometimes wonder itself has value. Sometimes uncertainty enriches experience. Sometimes unanswered questions encourage humility. The universe has existed for nearly 14 billion years. Human science has explored it seriously for only a tiny fraction of that time. There is no shame in not possessing every answer. Indeed, perhaps wisdom begins with recognizing how much remains unknown. The night grows deeper. The room feels softer. Thoughts drift more slowly. Outside, winds may move through trees. Clouds may cross the moon. Distant waves may rise and fall against unseen shorelines. Nature rarely hurries. A forest may require centuries to mature. Coral reefs develop over generations. Glaciers reshape landscapes through patient movement, almost too slow to notice. The quantum world exists on scales unimaginably smaller than forests or glaciers. Yet it shares a certain patience. Its processes unfold continuously, quietly, endlessly, invisible beneath everyday awareness, and still they shape everything. Another extraordinary phenomenon now emerges from the darkness. quantum entanglement, perhaps the most astonishing idea in all of physics. When certain particles interact, their properties can become linked in ways that challenge ordinary intuition. The particles cannot be fully described independently. Instead, the system must be considered as a whole. Changes in measurement outcomes reveal correlations that puzzled physicists for decades. The implications appeared so strange that even some of the founders of quantum theory found them unsettling. Yet, experiment after experiment confirmed the predictions. Reality once again proved more subtle than expectation. Imagine two leaves carried away by a river. They drift apart, farther and farther, around bends, past rocks, toward distant places. Yet suppose their stories remained connected in some profound way despite the separation. Entanglement is not literally this, but the image captures a feeling, a sense that separation may not always mean complete independence. Modern experiments demonstrate these correlations with extraordinary precision. Quantum information science has emerged partly from this remarkable phenomenon. New technologies continue to grow from principles that once seemed almost philosophical. And perhaps that is another recurring pattern in science. Ideas that begin as mysteries often become tools. Questions become understanding. Wonder becomes knowledge. Yet knowledge does not eliminate wonder. It deepens it. The ocean remains beautiful after we learn how tides work. Stars remain magnificent after we understand fusion. Mountains remain inspiring after geology explains their formation. Understanding often expands, all rather than reducing it. In the silence of deep space, photons continue their journeys across billions of kilometers. Some began traveling before human civilization existed. Some left their stars before pyramids were built. Some departed before forests grew where cities now stand. Light itself carries quantum properties. It arrives in discrete packets called quanta. The very word quantum emerged from this realization. Nature, at its deepest levels, often changes in distinct increments rather than perfectly continuous flows. A staircase rather than a ramp, a rhythm rather than a blur. The discovery transformed physics. It opened doors into entirely new landscapes of thought. And yet the stars continued shining exactly as before. The oceans continued moving. The seasons continued turning. Reality changed only in our understanding of it. The universe itself remained quietly busy, as always, and perhaps there is comfort in that as well. Truth does not require recognition to exist. Stars shone before astronomers. Mountains stood before geologists. Quantum mechanics governed atoms long before physicists discovered it. Reality patiently waits for understanding. It never demands it. It simply is. The darkness grows deeper. The thoughts grow softer. The strange and beautiful quantum world continues beneath every object around you, within every breath, within every heartbeat, within every grain of dust drifting through moonlight. And as sleep slowly approaches, the universe continues its endless work. Silent, ancient, mysterious. and extraordinarily gentle. As the night continues its quiet journey, let us move even deeper into the landscape of quantum mechanics, where certainty becomes softer and the boundaries between ideas begin to resemble distant shorelines disappearing into fog. One of the most important discoveries in modern physics is that particles are not quite what we once imagined them to be. When people first learned about atoms, it was tempting to picture them as miniature solar systems, tiny planets orbiting tiny suns. Neat, orderly, predictable. Image was helpful, but reality turned out to be more subtle. Electrons do not travel around atomic nuclei like planets circling stars. Instead, they occupy regions of probability, cloud-like distributions, patterns of possibility, invisible structures described by mathematical waves. Imagine walking through an ancient forest before dawn. Mist hangs between the trees. The air feels cool and still. Moonlight drifts softly through branches. You know birds are present somewhere among the leaves. You hear occasional movements, yet you cannot point to their exact locations. You perceive a distribution of possibilities, a presence spread throughout the forest. Atomic electrons are not birds, and probability clouds are not mist. Yet the atmosphere of uncertainty feels strangely similar. The deeper scientists looked, the less the universe resembled a collection of tiny objects, the more it resembled relationships, patterns, fields, possibilities. And perhaps there is something beautiful about that. After all, many important things in human life are difficult to point at directly. Friendship, memory, hope, love, they exist. Their effects are real, yet they often resist simple description. Not everything meaningful fits neatly inside a box. Far beneath the surface of the Pacific Ocean, where darkness has remained nearly unbroken for millions of years, strange creatures move through cold water. Many produce their own light, tiny flashes, gentle glows, soft illuminations in an otherwise black environment. Bioluminescent organisms create entire constellations beneath the sea, invisible to most of humanity, yet present nonetheless. The quantum world often feels similar, an entire hidden layer of reality glowing beneath ordinary experience, a hidden architecture supporting the visible world, a quiet framework beneath familiar appearances. Now, let us consider something called the uncertainty principle. This idea is frequently misunderstood. It is not merely a statement about imperfect measuring devices, nor is it a declaration that scientists are careless or limited. Instead, it reflects something fundamental about nature itself. Certain pairs of properties cannot both be known with unlimited precision at the same time. Position and momentum provide the most famous example. The more precisely one is defined, the less precisely the other can be specified. This is not because information is being hidden from us. It is because the quantum world itself operates according to principles different from everyday expectations. Imagine trying to describe a wave crossing a moonlit lake. You may focus carefully on where the wave is located, or you may focus on how it is moving. But there are limits to how perfectly both descriptions can coexist. Quantum reality contains similar trade-offs, not because nature is flawed, because nature is structured differently than common intuition suggests. Long before modern physics, people often dreamed of perfect knowledge, a complete map of reality, a final understanding, a position from which every question could be answered. Quantum mechanics introduced a quieter possibility. Perhaps complete certainty is not available, not because we have failed, but because reality itself contains intrinsic limits. And strangely, this realization can feel comforting. The universe does not require us to know everything. The stars do not demand complete understanding. The oceans do not insist that every depth be measured. Mystery is not always a problem waiting to be solved. Sometimes mystery is part of the beauty. Elsewhere in the universe, planets drift around distant stars. Some are worlds of ice. Some are oceans without continents. Some may possess skies colored in shades unknown on Earth. On many of these worlds, quantum mechanics operates exactly as it does here. The same principles, the same probabilities, the same hidden architecture beneath matter and light. It is remarkable to imagine. The laws discovered by human beings on one small planet appear to govern reality across immense cosmic distances. The atom in your hand and the atom inside a distant star obey the same underlying rules. The universe possesses a kind of coherence, a unity spread across extraordinary scales, and perhaps that unity offers a quiet form of comfort. Though we often feel small, we are not separate from the cosmos. We are expressions of it, participants within it, made from the same ingredients as stars and galaxies, the same ancient matter, the same quantum fields, the same fundamental reality. The night grows deeper. Some listeners may already be drifting toward sleep. Others may be staring into darkness while thoughts wander gently through these strange ideas. Both are perfectly welcome. Quantum mechanics rewards slow listening. The concepts do not reveal themselves all at once. They unfold gradually, like coastlines emerging through morning fog, like stars appearing one by one as daylight fades, like memories returning quietly after many years. Another remarkable concept now approaches: vacuum fluctuations. At first glance, empty space seems simple. Nothingness appears straightforward. Void and absence, a blank canvas. Yet quantum physics discovered something astonishing. Even empty space is not entirely empty. Quantum fields permeate the universe, and those fields possess activity even in their lowest energy states. Tiny fluctuations arise, brief events, momentary disturbances, subtle processes unfolding beneath apparent emptiness. Imagine standing beside a perfectly calm lake. From a distance, the surface appears motionless. Yet closer inspection reveals tiny ripples, small disturbances, minute patterns. No matter how still things seem, hidden motion often remains. The quantum vacuum shares something of that character. A quiet sea beneath reality, never completely inactive, never completely silent. This idea helped transform modern physics. The emptiness between stars became more interesting than anyone had imagined. Space itself acquired texture, depth, character. The void was not merely absence. It became a participant in the story. And perhaps there is a philosophical lesson hidden there as well. What appears empty is not always empty. What appears silent is not always silent. What appears still may contain hidden movement. A deserted beach retains traces of countless waves. An abandoned observatory retains echoes of forgotten observations. A quiet room contains invisible currents of air. The universe is often richer than appearances suggest. Far beyond our galaxy, immense structures span the cosmos. Clusters of galaxies gather together through gravity. Great filaments stretch across space. Vast regions of relative emptiness, separate islands of light. The observable universe resembles a cosmic web, an architecture so large that human language struggles to describe it. And yet, this magnificent structure ultimately emerges from tiny fluctuations in the early universe. Small differences, small variations, small quantum events. The largest patterns we observe today may owe their existence to microscopic uncertainties present billions of years ago. There is something deeply poetic about that. Immense emerging from the tiny, the grand emerging from the subtle, the visible emerging from the invisible. A similar pattern appears throughout nature. Forests begin with seeds. Coral reefs begin with tiny organisms. Mountains begin with geological processes almost too slow to perceive. Great things often arise from humble beginnings, quiet beginnings, beginnings easy to overlook. Now let us sit for a moment with the concept of time. Quantum mechanics changed our understanding of many things. Yet time remains one of the deepest mysteries in all of science. We experience it continuously. The movement of hours, the passage of seasons, the aging of faces, the growth of forests, the erosion of coastlines. Time feels immediate, obvious, yet physicists continue debating its ultimate nature. Some theories treat time as fundamental. Others suggest it may emerge from deeper structures. Questions remain open. The mystery persists. Imagine an old lighthouse standing beside a stormy coast. Generations come and go. Ships arrive and depart. Storms rise and fade. The lighthouse remains, watching, enduring. Time flows around everything. And yet, when we examine the deepest layers of reality, its nature becomes surprisingly elusive. Perhaps this is fitting. After all, time is the medium through which every human experience unfolds. Love requires time. Memory requires time. Learning requires time. Healing requires time. Sleep itself requires time. The very act of listening to these words depends upon the steady passage of moments. And tonight those moments move gently, without urgency, without pressure, without demand. Only the slow rhythm of thought, the soft movement of ideas, the quiet unfolding of a universe that remains far stranger and far more beautiful than anyone expected. Outside, somewhere beyond roofs and trees and clouds, stars continue shining. Some are young, some are ancient, Some may already be gone, their final light still traveling toward Earth across immense distances. The cosmos carries countless stories, and quantum mechanics is one of the most extraordinary among them, not because it provides all the answers, but because it teaches us how mysterious reality truly is. It invites humility, patience, wonder, the willingness to sit beside uncertainty without fear. And perhaps that is one of the gentlest lessons science can offer, that not knowing everything is perfectly acceptable, that mystery can coexist with understanding, that questions can remain open, and that the universe remains beautiful regardless. The darkness deepens, the room softens, thoughts drift like distant clouds crossing a moonlit sky, and beneath every object around you, beneath every breath and heartbeat, beneath every memory and dream, the quantum world continues its endless, silent dance, patient as the deep ocean, ancient as starlight, quiet as falling snow, and still unfolding as midnight drifts quietly onward, and the world outside becomes softer and more distant. Let us continue our slow journey through the quantum landscape. There is no destination waiting for us, no final mountain peak, no ultimate answer glowing at the horizon, only a long wandering through one of the most beautiful mysteries ever encountered by the human mind. And perhaps that is enough. Perhaps the wandering itself is the gift. One of the curious features of quantum mechanics is that it often asks us to abandon familiar pictures of reality. For thousands of years, human beings understood the world through direct experience. Stones fell downward, fire rose upward, water flowed downhill, the moon crossed the sky, the seasons returned. These observations were reliable. They helped people survive. They helped civilizations grow. But the quantum world exists far beyond ordinary experience. No human evolved to intuitively understand particles smaller than atoms. No ancient hunter gazed across a valley and developed instincts for wave functions. No sailor crossing an ocean learned to navigate using quantum probability amplitudes. The microscopic world operates according to rules that lie far outside everyday perception. And so quantum mechanics requires something unusual. It asks us to trust evidence even when intuition protests. It asks us to follow mathematics into regions where common sense begins to lose its footing. This is not weakness. It is courage. The willingness to discover that reality may be stranger than expectation. Far beneath the surface of the Atlantic Ocean, cold currents move through darkness. These currents travel enormous distances. Some began their journeys decades ago. Some transport water across entire oceans, slow rivers hidden beneath the sea, invisible pathways connecting distant places. The quantum world contains similar hidden connections, not rivers of water, but mathematical relationships, structures beneath appearances, invisible patterns guiding physical events. Most of reality unfolds beyond direct perception. The air itself is invisible. Gravity cannot be seen. Magnetic fields reveal themselves only through effects. And quantum mechanics reminds us that many of nature's deepest processes occur in realms beyond ordinary awareness. Yet, they are no less real. A tree does not need to understand photosynthesis in order to grow. A star does not need to comprehend fusion in order to shine. Reality works quietly whether or not it is observed, and there is something deeply comforting in that. The universe carries on, patiently, faithfully, without requiring our supervision. Now let us drift toward another remarkable idea. Quantum fields. Modern physics increasingly suggests that the fundamental ingredients of reality may not be particles at all. Instead, fields appear to occupy a more foundational role. A field extends throughout space. It exists everywhere. Particles may be understood as localized excitations within these fields, tiny ripples, small disturbances, momentary patterns. Imagine standing beside a vast ocean at night. The sea stretches beyond the horizon, dark, endless, almost impossible to comprehend fully. Waves rise from its surface. They appear, travel, fade away. Yet the ocean remains. The waves are not separate from the sea. They are expressions of it. Quantum fields possess a similar elegance. Electrons may be viewed as excitations within an electron field. Photons emerge from the electromagnetic field. Reality begins to resemble an immense interconnected fabric, not isolated objects scattered through emptiness, but patterns emerging within deeper structures. This perspective changes how we think about existence itself. The world becomes less like a collection of things, more like a collection of relationships, less like machinery, more like music, a symphony of interactions unfolding across space and time. Elsewhere in the universe, galaxies rotate through darkness. Each contains billions of stars. Each star hosts its own story, its own chemistry, its own history. Yet all participate in the same underlying reality, the same quantum fields, the same physical laws, the same cosmic architecture. And perhaps there is a quiet beauty in that unity. The atom within a distant galaxy and the atom within your body belong to the same universe. They share the same foundations, the same hidden language written beneath existence. Long before human civilization emerged, those foundations were already present, waiting, patient, ancient beyond imagination. The room around you grows still. Perhaps you can hear distant sounds fading into the background, a faint breeze, a settling building, the whisper of leaves beyond a window. The world often becomes most peaceful when attention softens, when urgency recedes, when thoughts stop demanding immediate answers. Quantum mechanics rewards that kind of patience. The more gently we approach it, the more its strange beauty begins to reveal itself. Let us now consider light. For centuries, light remained one of nature's greatest mysteries. It illuminated forests, reflected from oceans, painted mountains gold at sunrise, crossed enormous cosmic distances. Yet its true nature remained elusive. Then came the realization that light arrives in discrete packets, tiny bundles of energy known as photons. This discovery helped launch the quantum revolution. Suddenly, Light possessed characteristics of both waves and particles. The universe once again refused to fit neatly inside existing categories. And perhaps that is one of reality's recurring habits. Whenever we become too comfortable with our assumptions, nature gently reminds us that it is under no obligation to match them. The stars did not arrange themselves according to human expectations. The oceans did not shape themselves around human intuition. Quantum mechanics did not emerge to satisfy common sense. Reality simply reveals itself as it is, and our task is to listen carefully, to observe patiently, to learn. In the silence of deep space, photons travel for millions or even billions of years. Some began their journeys before Earth possessed complex life. Some left their stars before dinosaurs existed. Some are still traveling tonight, crossing unimaginable distances through darkness. Silent messengers moving between worlds. Eventually, a few of them reach telescopes, retinas, camera sensors, and suddenly information arrives. A distant galaxy becomes visible. An ancient event becomes known. The past touches the present through light. There is something profoundly beautiful about that. The night sky is not merely a collection of distant objects. It is a conversation across time, a slow exchange between ancient stars and curious minds. And quantum mechanics lies at the heart of that conversation. Without it, there would be no starlight, no chemistry, no life, no observers wondering about the universe. The very existence of questions depends upon quantum foundations. Now let us wander into a topic that sounds almost magical: quantum interference. When quantum waves overlap, they can reinforce or cancel one another. The resulting patterns reveal some of the deepest aspects of quantum behavior. Experiments demonstrate this with remarkable clarity. Even individual particles can produce interference effects under appropriate conditions. The implications are extraordinary. Reality behaves in ways that challenge ordinary categories. Imagine moonlight reflecting across gentle water. Ripples spread outward. Patterns intersect. Bright regions emerge. Dark regions form. The surface becomes a living tapestry of overlapping waves. Quantum interference possesses a similar elegance. Possibilities interact. Paths combine. Patterns emerge. The mathematics is precise, yet the visual imagery feels almost poetic. Nature creates structures from overlap, from interaction, from relationships, and perhaps life itself often follows the same principle. No person exists entirely alone. Every life intersects with others. Every story touches countless stories. Every action contributes to larger patterns. The forest depends upon relationships among trees, fungi, insects, soil, and water. The ocean depends upon relationships among currents, organisms, temperature, and light. The universe itself may be understood through relationships more than isolated objects. Quantum mechanics quietly points in that direction again and again. Far above the clouds, high-energy particles continuously arrive from space. Cosmic rays cross enormous distances before reaching Earth's atmosphere. Some originate from violent events in distant galaxies. Some emerge from exploding stars. Others arise from processes still not fully understood. When these particles collide with the atmosphere, showers of secondary particles spread through the sky. Invisible rain from the cosmos. Evidence that Earth remains connected to the wider universe. Even now, while the night deepens and thoughts slow, cosmic particles pass through the world around you. Most continue unnoticed. Silent travelers crossing space and time. The universe is not distant. It is here, present, flowing through every moment. And quantum mechanics forms part of that ongoing story. Not merely an abstract theory, not merely equations in textbooks, but a description of processes occurring everywhere. Within stars, within oceans, within forests, within your own body. Every heartbeat depends upon chemistry. Every chemical bond depends upon quantum rules. Life itself is woven from microscopic events, unfolding continuously. And somehow, from those events, consciousness emerges. Awareness emerges. Dreams emerge. Memories emerge. The fact that matter can organize itself into beings capable of contemplating the cosmos remains one of the greatest wonders of all. Atoms learned to ask questions. Stardust became curious. The universe developed the ability to observe itself. And perhaps that realization deserves a moment of quiet reflection. For billions of years, galaxies spun through darkness. Stars ignited and faded. Planets formed and vanished. Then, on at least one small world, matter assembled into living organisms. Some eventually began wondering about existence, wondering about time, wondering about reality, wondering about quantum mechanics. The cosmos became self-aware, at least in a tiny and fragile way. And here tonight, as sleep gradually approaches, that long story continues. A listener in the darkness, a mind drifting through thoughts, a small consciousness carried through an ancient universe, surrounded by mysteries, supported by invisible quantum foundations, connected to stars older than imagination. The night remains vast. The universe remains patient. And there is no need to hurry. The answers have waited billions of years. They can wait a little longer. For now, it is enough simply to listen. Enough simply to wonder. Enough simply to be. The deeper the night becomes, the more the world seems to simplify. Colors fade into shadows. Distant landscapes disappear into darkness. The busy details of daytime soften. What remains are outlines, shapes, gentle sounds, the slow rhythm of existence itself. Quantum mechanics can feel similar. The deeper we travel into its foundations, the more familiar categories begin to dissolve. The universe becomes less concerned with solid objects and more concerned with patterns. Less concerned with permanence and more concerned with relationships. Less like a collection of separate pieces and more like a vast, interconnected tapestry. And so tonight, we continue our wandering, slowly, patiently, as though walking beneath ancient stars along a quiet shoreline. One of the questions physicists often ask is surprisingly simple. Why do large objects not appear quantum? Why do baseballs not seem to exist in multiple states? Why do mountains not display obvious interference patterns? Why does the everyday world appear so stable and definite? The answer involves a process known as decoherence. The word sounds technical, yet the idea can be approached gently. Quantum systems rarely exist in complete isolation. They constantly interact with their surroundings, with air, with light, with nearby particles, with the environment itself. These countless interactions gradually disperse delicate quantum information. The result is that large-scale objects begin to behave in ways that appear classical. The strange possibilities of the quantum world become hidden beneath layers of environmental interaction. Imagine a perfectly still pond at dawn. A single ripple forms. Its pattern is elegant, precise, beautiful. But now imagine wind arriving, rain beginning, leaves touching the surface, countless disturbances overlapping. The original ripple becomes difficult to distinguish. Its information has not vanished entirely, but it has spread into a larger system. Decoherence shares something of that spirit. The quantum world remains present. It has not disappeared, but its most delicate features become increasingly difficult to observe. And perhaps there is something poetic in that. The deepest structures of reality continue supporting the visible world, even when they remain hidden from direct experience. Much of existence works this way. Tree roots remain invisible beneath soil. Ocean currents move unseen beneath waves. The foundations of mountains lie buried beneath their slopes. What is hidden is often essential. Far beneath Earth's crust, immense forces move continents. They do so slowly that a human lifetime can barely perceive the motion. Yet over millions of years, entire oceans open and close. Mountain ranges rise, landscapes transform. The greatest changes are often the quietest. Quantum processes share this subtle character. They operate continuously, patiently, without announcement, without spectacle. The universe rarely shouts. Most of the time it whispers. Now let us consider another extraordinary aspect of the quantum world. The fact that nature can sometimes appear fundamentally random. This idea unsettled many scientists when it first emerged. For centuries, physics had moved steadily toward greater predictability. Given enough information, it seemed possible to calculate the future. Then quantum mechanics arrived, and suddenly probability stood at the center of the stage. Not ignorance, not approximation, probability itself. A quantum event may possess several possible outcomes. Physics can predict the probabilities with astonishing accuracy. Yet the exact result remains uncertain until the event occurs. This is one of the deepest features of quantum theory, and one of the most debated. Some physicists accept it as fundamental. Others search for deeper explanations. The discussion continues. The mystery remains alive. Imagine standing beside the sea during a gentle fog. You know waves are approaching. You understand the general rhythm. You can predict that water will reach the shore. Yet the exact shape of each wave remains unknown until it arrives. Reality possesses patterns. but not always certainties. The future contains structure, yet it also contains openness. Perhaps this balance between order and possibility is part of what makes the universe so creative. Stars form, planets emerge, life evolves, new arrangements become possible. The cosmos is not frozen. It is dynamic, inventive, capable of producing endless variation from a shared set of underlying laws. Elsewhere among the stars, worlds may exist where oceans stretch across entire hemispheres. There may be planets where rain falls for centuries, planets where ice mountains rise beneath unfamiliar constellations, planets illuminated by multiple suns, worlds so strange that human imagination struggles to picture them. And yet, every one of those worlds, if they exist, would still be built upon the same quantum foundations, the same invisible architecture, the same delicate mathematics governing matter and energy. There is something beautiful about that consistency, a hidden unity beneath enormous diversity, like countless melodies emerging from the same musical scale, like countless rivers flowing through the same landscape, like countless dreams arising within the same sleeping mind. The universe is vast beyond comprehension, yet it remains connected. The night outside continues its quiet unfolding. Somewhere waves strike distant coastlines. Somewhere snow falls across silent mountains. Somewhere deserts cool beneath starlight. Somewhere migratory birds cross dark skies. And everywhere, beneath every environment, beneath every ecosystem, beneath every stone and leaf and drop of water, quantum events continue. Invisible, constant, faithful. The foundations never sleep. They simply continue, moment after moment, year after year, age after age. Now let us spend some time with one of the most astonishing achievements in modern science: quantum electrodynamics. The name itself sounds immense, and in many ways it is. This theory describes how light and matter interact. Its predictions have been tested with extraordinary precision. Again and again, experiments confirm its accuracy. Some measurements agree with theory to a degree so exact that it almost seems unbelievable. Imagine constructing a map detailed enough to predict the location of a single grain of sand on an entire coastline. Then imagine the map proving correct. Again and again, quantum electrodynamics achieves a level of agreement between theory and observation that ranks among the greatest successes in scientific history. Yet despite its precision, the underlying reality it describes remains wonderfully strange. Nature does not become less mysterious simply because our calculations improve. In many cases, understanding reveals new layers of wonder. The deeper we look, the deeper the mystery seems to become. Far from Earth, ancient starlight crosses immense regions of space. Some photons have traveled longer than human civilization has existed. Some began their journeys before our species evolved. These tiny messengers carry information across cosmic time. They tell stories of distant stars, ancient galaxies, forgotten eras of the universe. Every night sky is a museum of the past, every star a historical document, every beam of light a traveler arriving from another age. And quantum mechanics helps explain how these travelers behave, how they move, how they interact, how they reveal distant worlds. The same theory that describes tiny particles also helps us understand the largest structures we can observe. The smallest and largest scales become connected. The microscopic and cosmic begin speaking the same language. And perhaps that is one of science's most beautiful discoveries. Reality is not divided into separate stories. It is one story, one continuous unfolding, from quantum fields to galaxies, from atoms to oceans, from starlight to dreams. Everything participates in the same universe, the same ancient process, the same unfolding mystery. As the hours drift onward, thoughts may begin to feel lighter, less fixed, more fluid. That is perfectly natural. The boundary between waking and sleep often resembles a shoreline, not a sharp edge, but a gradual transition, one world blending softly into another. Quantum mechanics contains many such transitions, wave becoming particle-like, possibility becoming outcome, microscopic uncertainty becoming macroscopic stability. Reality rarely changes through sudden divisions. More often it changes through subtle transformations, gentle shifts, gradual emergence. The dawn does not arrive instantly. The tide does not reverse all at once. A forest does not appear overnight. The universe prefers patience, and perhaps we can learn from that. Perhaps not everything requires immediate resolution. Perhaps some questions benefit from time. Perhaps understanding itself grows like a tree, slowly, quietly, root by root, branch by branch, year by year. Now imagine an abandoned observatory standing alone on a remote mountain, its dome weathered by decades of wind, its instruments resting beneath layers of dust. The astronomers who once worked there have long since departed, their notebooks faded, their voices silent. Yet above the observatory, the stars remain, still shining, still moving, still obeying the same quantum laws they followed long before human beings arrived. There is a certain humility in that image. Civilizations rise and fall. Generations come and go. Individual lives flicker briefly against the backdrop of cosmic time. Yet the universe continues, ancient, patient, steady, not indifferent exactly, simply vast, vast beyond ordinary language. And perhaps that vastness need not feel frightening. Perhaps it can feel comforting, a reminder that we do not carry the weight of existence alone. The cosmos existed before us. It will continue after us. For now, we are participants in its story. Small participants, brief participants, but participants nonetheless, made from ancient atoms, guided by ancient laws, living for a little while beneath ancient stars. The quantum world continues its silent dance, within every cell, within every breath, within every beam of moonlight crossing the floor. And as sleep draws nearer, the mysteries remain, not demanding answers, not demanding conclusions, only offering wonder, only inviting curiosity, only reminding us that reality is deeper than appearances and far more beautiful than certainty alone could ever be. As the night settles into its deepest hours, there is a peculiar stillness that arrives in many places. Roads grow quiet, windows darken. The conversations of the day slowly dissolve into memory. Even the wind sometimes seems to soften, as though the world itself has become drowsy. This is a fitting time to think about the hidden foundations of reality, because quantum mechanics is, in many ways, a science of things that cannot be seen directly, not because they are secret, not because they are deliberately concealed, but because they exist on scales so small that ordinary human experience never evolved to notice them. And yet, these invisible processes support everything: the floor beneath you, the air around you, the distant stars beyond the clouds, even the thoughts drifting gently through your mind. All are built upon layers of reality that remain forever beyond direct perception. And somehow there is comfort in that. Not everything important must be visible. Not everything essential must announce itself. A tree depends upon roots hidden beneath soil. An island depends upon foundations beneath the sea. Life depends upon processes occurring quietly inside cells. The most important things are often hidden. Far beneath the Arctic Ocean, immense currents move through darkness. Above them, ice drifts. Storms pass. Seasons change. Yet the deep currents continue their ancient journeys. Steady, persistent, almost invisible. Quantum processes possess a similar quality. A hidden continuity beneath the changing surface of experience. A silent architecture beneath everyday life. One of the most fascinating aspects of modern physics is that the universe appears to be built from a surprisingly small collection of fundamental ingredients. The variety around us feels endless. Forests, mountains, birds, clouds, whales, deserts, cities, rivers, galaxies. Yet beneath this astonishing diversity lies a relatively small set of particles and fields interacting according to elegant rules. Nature achieves extraordinary complexity from simple foundations, like a symphony emerging from a limited number of notes, like an entire language emerging from a finite alphabet, like countless waves arising from a single ocean. This tendency toward simplicity beneath complexity appears again and again throughout science. The deeper we look, the more unity we often discover. The universe does not seem interested in unnecessary complication. Instead, it builds wonders from fundamentals. A forest is composed of cells. Cells are composed of molecules. Molecules are composed of atoms. Atoms emerge from deeper structures, and beneath those structures, quantum fields quietly extend throughout space. Reality resembles a great hierarchy of patterns, each level emerging from the one below, each layer resting upon deeper foundations. And perhaps human life mirrors this structure. Entire civilizations emerge from individuals. Cultures emerge from relationships. Histories emerge from countless small moments. Large things often grow from small beginnings, quiet beginnings, beginnings almost impossible to notice at first. Now let us spend some time thinking about symmetry. Physicists often speak of symmetry with a kind of reverence, not because it is merely beautiful, though it often is, but because symmetry appears deeply connected to the laws of nature. A symmetry exists when certain transformations leave something unchanged. A snowflake rotated by a specific angle may appear identical. A circle looks the same from every direction. Certain physical laws remain unchanged under particular transformations. And remarkably, these symmetries help determine how reality behaves. Imagine standing in an ancient stone temple illuminated only by moonlight. Massive pillars rise into darkness. Geometric patterns repeat across walls worn by centuries. There is a sense of order, a quiet balance, an underlying structure. Nature often exhibits a similar elegance, not always obvious, not always visible immediately, but present, waiting to be discovered. The universe seems to possess a fondness for harmony, not perfect harmony, not absolute simplicity, but recurring patterns woven through existence. The spirals of galaxies, the structures of crystals, the rhythms of planetary motion, the mathematical symmetries hidden within quantum theory. Again and again, order emerges, and yet mystery remains. The two coexist, as perhaps they always will. Elsewhere in the universe, stars are dying, not violently in every case. Some fade gradually, their fuel slowly diminishing, their light changing over immense spans of time. Others end more dramatically, expanding, collapsing, exploding, returning material to space. The atoms inside your body were forged in ancient stars. Carbon, oxygen, nitrogen, iron. These elements were created through cosmic processes long before Earth existed, long before oceans formed, long before forests spread across continents, long before human beings began wondering about quantum mechanics. The matter composing you has traveled an extraordinary journey, billions of years, countless transformations, ancient stars, interstellar clouds, planetary formation, biological evolution, and now consciousness, now awareness, now the ability to contemplate the universe itself. There is something deeply moving about that. The atoms do not remember their journey, yet the journey happened. The universe carried them through time until eventually they became part of a living being capable of wonder. Perhaps wonder is one of the cosmos's most remarkable achievements. Now let us return to the quantum world. There exists a famous question often asked by physicists and philosophers. What is the wave function? Not merely what does it calculate, not merely how does it behave, but what is it fundamentally? Different interpretations offer different answers. Some treat it as a real physical entity. Others view it as information. Others suggest entirely different perspectives. The mathematics works beautifully regardless, yet the deeper meaning remains debated. Imagine several travelers standing beside the same ocean at night. One describes the waves, another describes the moonlight, another describes the wind, another describes the smell of salt in the air. All are observing the same reality, yet each perspective highlights different aspects. quantum interpretations often feel similar. Different ways of understanding the same successful theory. Different stories told about the same underlying mathematics. And perhaps reality is spacious enough to invite multiple viewpoints while still remaining itself. After all, mountains look different from different valleys. The ocean appears different at dawn than at midnight. A forest changes with the seasons. Perspective matters. And science often advances by exploring many perspectives before gradually discovering deeper clarity. The room around you may feel quieter now. Thoughts may be moving more slowly. The edges of wakefulness becoming softer. That is perfectly fine. In fact, quantum mechanics and sleep share a curious similarity. Both invite us beyond ordinary certainty. Both remind us that consciousness is not the only way reality exists. While we sleep, stars continue burning. Waves continue crossing oceans. Forests continue breathing. Quantum fields continue fluctuating. The universe does not pause. It continues its patient unfolding. Night after night, century after century, age after age. In the silence of deep space, far from planets and suns, there are regions so empty that a traveler might drift for years without encountering significant matter. Great cosmic voids, immense expanses of darkness, distances difficult to imagine. And yet even there, quantum fields remain present. Even there, the fabric of reality persists. There is no true escape from existence. No place entirely outside the universe. The cosmic story extends everywhere. Across every galaxy. Across every star. Across every grain of dust floating between worlds. And somehow, despite this vastness, the same fundamental laws continue operating. The same equations, the same fields, the same quantum principles. The universe is astonishingly large, yet astonishingly unified. A single story told across unimaginable scales. Now imagine a snowfall in a remote forest. The flakes descend slowly through moonlit air. No two exactly alike, each following its own path. The forest becomes quieter with every passing moment. The landscape softens beneath white layers of accumulation. From countless individual events emerges a transformed world. Quantum mechanics often reveals similar patterns. Individual probabilities combine into stable realities. Countless microscopic interactions produce the macroscopic world we recognize. The familiar emerges from the unfamiliar. The ordinary emerges from the extraordinary. Everyday experience rests upon foundations stranger than dreams. And yet, because those foundations are so reliable, the world feels stable. The sunrise arrives. The seasons return. The stars appear. Life continues. The mystery remains hidden beneath familiarity. Perhaps that is one reason the universe feels so beautiful. It contains depths beneath depths, layers beneath layers, questions beneath questions. No matter how much we learn, there is always more waiting beyond the horizon. More stars beyond the visible stars. More oceans beneath the surface. More mysteries within reality itself. And that endless depth need not be troubling. It can be reassuring. a reminder that wonder never truly runs out, a reminder that curiosity will always have somewhere to travel, a reminder that existence remains larger than any explanation. The night deepens further. The darkness grows gentle. The quantum world continues its invisible dance beneath every object around you. Ancient fields stretching through space, tiny fluctuations arising and fading, particles appearing as ripples within deeper structures. A cosmos built from patterns more subtle than anyone once imagined. And above it all, the stars continue their silent journey through the darkness, patient, enduring, calm, just as they have for billions of years, just as they will long after tonight has become a memory. And for now, there is nothing to do but drift with the story, to listen, to wonder, and perhaps, little by little, to sleep. The universe often reveals its deepest truths in unexpected ways, not through thunder, not through grand announcements, but through careful observation, through patience, through long years spent listening to nature's quiet answers. Many of the discoveries that shaped quantum mechanics emerged from scientists noticing small details, tiny discrepancies, subtle patterns, gentle hints that reality was more complex than it first appeared. A faint shift in light, an unusual measurement, a result that refused to fit existing expectations. The history of science is filled with such moments, moments when the universe whispered instead of shouted, and someone happened to be listening. Imagine an old observatory standing alone beneath a winter sky. Snow gathers along stone walls. The telescope points toward distant stars. Inside, a lone astronomer waits quietly beside notebooks and lantern light. Hour after hour, observation follows observation. Most nights reveal nothing unusual, yet occasionally a small detail appears. A clue, a puzzle, a doorway into deeper understanding. Quantum mechanics began, in many ways, through countless moments like these. Patient people paying attention, patient enough to notice that reality was trying to tell a different story. One of the most remarkable lessons of quantum theory is that nature often refuses simple categories. We prefer clear distinctions, wave or particle, here or there, this or that. Human thinking naturally seeks boundaries, yet the quantum world repeatedly blurs them. Light behaves like a wave in some circumstances, like a particle in others. Electrons display characteristics that seem to belong to both descriptions. The universe appears less interested in our categories than we are. Reality simply exists. Our labels come afterward. And perhaps this extends beyond physics. Many things in life resist simple classification. A coastline is neither entirely land nor entirely sea. Twilight is neither fully day nor fully night. Memory belongs partly to the past and partly to the present. The most interesting things often exist between categories, in transitions, in boundaries, in places where definitions become soft. Far out at sea, there are regions where warm currents meet cold currents. These boundaries create extraordinary environments. Life flourishes there. Nutrients circulate. Patterns emerge. The meeting place becomes richer than either side alone. Quantum mechanics often inhabits such meeting places, between certainty and uncertainty, between waves and particles, between mathematics and philosophy, between what we know and what remains mysterious. And perhaps that is why it continues to fascinate people. It reminds us that reality is larger than any single perspective. The night air outside may have grown cooler by now. Clouds may be crossing overhead. Perhaps moonlight is drifting across rooftops or fields or quiet streets. The world continues its gentle motion, even when we are still, even when we sleep, even when we dream. Earth rotates, oceans move, stars shine, quantum fields fluctuate. The cosmos never truly stops, yet its motion is often so graceful that it feels peaceful rather than hurried. There is a profound difference between movement and rush. The universe moves constantly, but it rarely rushes. Galaxies evolve over billions of years. Mountains rise over millions. Forests mature over centuries. Nature seems comfortable with patience, perhaps far more comfortable than human beings often are. Now let us think about energy. One of the central ideas in quantum mechanics is that certain forms of energy appear in discrete amounts, not continuous, not infinitely divisible, but quantized. This realization was revolutionary. For centuries, many physical quantities had been treated as smoothly varying. Then, evidence began accumulating that nature sometimes prefers specific increments, specific steps, specific allowed values. Imagine a staircase illuminated by soft moonlight. You may stand on one step or another, but not halfway between them. Certain quantum systems exhibit something similar. Electrons in atoms occupy specific energy levels. Transitions occur between allowed states. Nature reveals a subtle granularity hidden beneath apparent continuity. This does not make the universe mechanical. If anything, it makes it more interesting. Reality possesses texture, structure, and intricate architecture beneath appearances. And from these tiny quantized transitions emerge many of the phenomena we observe. The colors of stars, the behavior of atoms, the chemistry of life, the existence of matter itself, all connected to quantum rules operating quietly beneath everyday awareness. Elsewhere in the cosmos, nebulae drift through darkness. Great clouds of gas illuminated by nearby stars. Some resemble glowing rivers. Some resemble pillars. Some resemble immense celestial gardens suspended in space. These structures appear calm when viewed through telescopes, yet they are dynamic environments. Atoms collide, radiation travels, magnetic fields twist, quantum interactions occur endlessly. Even the most tranquil cosmic landscapes are alive with activity. The same is true of stillness itself. A quiet room may appear inactive, yet air molecules move, heat flows, cells function, thoughts arise. The appearance of stillness often conceals enormous complexity. The universe is rarely motionless. It is simply moving in ways we do not immediately perceive. And perhaps that idea contains its own kind of comfort. Progress does not always look dramatic. Growth does not always look obvious. Change can occur quietly, slowly, patiently. like roots extending beneath soil, like stars forming inside distant clouds, like understanding deepening one gentle insight at a time. Now let us wander toward one of the most profound connections in modern physics, the relationship between information and reality. Over the past century, many physicists have come to appreciate that information plays a surprisingly important role in understanding nature. Quantum systems can carry information, store information, transfer information, process information. The universe increasingly resembles something more subtle than a collection of objects. It begins to resemble a vast network of relationships and information. Imagine a forest after fresh snowfall. The trees remain, the landscape remains, yet what catches your attention are the patterns: tracks crossing the snow, shapes in the branches, signs of movement, information woven into the environment. The world tells stories through patterns. Quantum mechanics reveals similar storytelling at microscopic scales. Particles carry traces of interactions. Measurements reveal histories. Correlations connect distant events. Reality becomes readable, not completely, not perfectly, but enough to glimpse deeper structure. And perhaps human existence depends upon information in profound ways. Memory is information. Language is information. Culture is information passed across generations. The story of civilization is, in part, the story of information moving through time. And beneath it all, quantum processes quietly support the physical world that makes such stories possible. The deeper we look, the more interconnected everything seems. Stars create elements. Elements create planets. Planets support life. Life develops awareness. Awareness studies stars. The circle closes. The cosmos observes itself through beings made from its own material. A remarkable arrangement. Perhaps the most remarkable arrangement we know. Far beneath the Pacific Ocean, hydrothermal vents release mineral-rich water into darkness. Around them flourish ecosystems unlike any found elsewhere on Earth. Life adapting to extreme conditions. Life finding opportunities where none seemed possible. Universe often surprises us in this way. Again and again, reality proves more inventive than expectation. Quantum mechanics taught scientists that nature possesses possibilities they had never imagined, and each new discovery revealed further questions waiting beyond it. Knowledge did not end mystery. Knowledge expanded mystery. Every answer opened additional doors. Every insight revealed larger horizons. The more we learn, the more we discover how much remains unknown. Yet this is not discouraging. It is beautiful. A universe with no mysteries would eventually become silent. A universe with endless depth remains forever inviting, forever interesting, forever worthy of wonder. The night continues. Thoughts drift more slowly now, like clouds crossing a dark sky, like waves moving across a sleeping sea, like leaves floating down a quiet river. There is no need to hold tightly to every idea. The concepts can come and go. The story can flow around you. Quantum mechanics does not require perfect concentration. It rewards curiosity, gentleness, patience. Even half-dreaming attention can appreciate its beauty, because beneath the equations and experiments lies something deeply simple, a realization that reality is richer than it appears, more subtle than it appears, more interconnected than it appears. The stars above, the oceans below, the forests, the mountains, the atoms, the photons, the thoughts moving through your mind, all belong to the same ancient universe. All arise from the same underlying reality. And that reality remains astonishing, not because it is loud, but because it is quiet, not because it demands attention, but because it patiently rewards it. The darkness grows softer still. The hours drift onward. The quantum world continues its endless work beneath every sleeping city and every silent landscape. And somewhere beyond the horizon, beyond clouds and oceans and continents, ancient starlight continues crossing the darkness, still traveling, still shining, still carrying its stories across the vast and patient universe. There is a particular kind of silence that sometimes arrives just before dawn, not complete silence. The universe rarely offers that. Instead, it is a layered silence, a silence containing distant sounds, the faint movement of air, the occasional settling of wood and stone, the quiet pulse of life continuing in darkness, a silence that feels alive. Quantum mechanics contains many such layers. At first glance, reality appears straightforward. Objects exist. Time passes. Stars shine. But beneath that familiar surface lies an intricate world of probabilities, fields, and relationships. A hidden landscape supporting everything we know. Tonight, we continue drifting through that landscape, not as hurried travelers, but as patient wanderers, moving slowly enough to notice the details. One of the most beautiful ideas in physics is that nature often achieves extraordinary complexity through simple rules. A snowflake forms from basic physical processes, yet no two snowflakes are exactly alike. Ocean waves emerge from simple interactions, yet every coastline displays unique patterns. Forests grow according to biological principles, yet each forest develops its own character. The universe appears remarkably creative, not because it constantly invents new laws, but because simple laws can generate endless variety. Quantum mechanics participates in this creativity. Its rules are precise. Its mathematics is elegant. Yet from those foundations emerge stars, planets, oceans, clouds, birds, trees, and people. An astonishing diversity arising from common principles. Imagine standing beside a river at twilight. The water flows according to physical laws. Gravity guides it. The riverbed shapes it. The landscape directs it. Yet no two moments of the river are identical. Patterns repeat without repeating exactly. Order and variation coexist. The quantum world often feels similar. Structure and possibility existing together. Lawfulness and unpredictability sharing the same space. And perhaps life itself depends upon that balance. A universe that was completely chaotic could not support complexity. A universe that was completely rigid might never produce novelty. Somewhere between those extremes lies the cosmos we inhabit, a place where stars can form, where life can emerge, where consciousness can awaken, where questions can be asked. Far beyond our galaxy, ancient light continues crossing the darkness. Many of those photons began their journeys long before human beings learned to write, long before cities rose beside rivers, long before the first ships crossed oceans. Their voyage has lasted longer than entire civilizations, and still they travel, patiently, steadily, obeying the same quantum principles every moment of the journey. There is something deeply calming about such consistency. The universe changes constantly, yet its foundations remain reliable. Stars are born and stars die. Continents drift. Species appear and disappear. Generations come and go. Yet the underlying laws continue. The same physics guiding events across billions of years. The same quantum fields extending through space. The same hidden architecture beneath existence. Perhaps reliability is one of the universe's quiet gifts. Not certainty about every event, but consistency in the deeper patterns. Enough stability for stars to shine. Enough stability for planets to orbit. Enough stability for life to grow. Enough stability for curiosity itself. Now let us think about scale. Quantum mechanics governs the smallest structures we can meaningfully describe. Yet somehow those microscopic processes contribute to the largest structures in existence. This connection between scales remains one of science's most extraordinary discoveries. The atom and the galaxy belong to the same story. The photon and the nebula belong to the same story. The quantum field and the cosmic web belong to the same story. Reality does not divide itself neatly into separate chapters. Everything participates in a continuous unfolding. Imagine a single grain of sand resting on a beach. Tiny, almost insignificant. Now imagine the coastline stretching for hundreds of kilometers. Then imagine the entire planet. Then the solar system. Then the galaxy. Then the observable universe. The differences in scale are almost impossible to comprehend. And yet all these layers remain connected. The grain of sand exists within the larger whole. The larger whole contains the grain of sand. The same is true of ourselves. Each person is small compared to a planet. A planet is small compared to a star. A star is small compared to a galaxy. A galaxy is small compared to the observable universe. Yet size alone does not determine significance. A single conscious moment possesses a value that measurements cannot fully capture. A brief experience of wonder, a quiet memory, a gentle conversation. These things matter, even within an enormous cosmos, perhaps especially within an enormous cosmos. The night sky often inspires humility because it reveals our smallness, but it can also inspire belonging. The atoms within us originated in ancient stars. The energy sustaining life ultimately traces back to cosmic processes. We are not outsiders looking in. We are participants, expressions of the same universe we seek to understand. The observer and the observed belong to the same reality. That thought has accompanied many scientists through long years of study, and perhaps it remains one of the most beautiful ideas in all of science. Now, let us drift toward another subtle topic: quantum fluctuations in the early universe. According to modern cosmology, tiny quantum variations present shortly after the beginning of cosmic history may have influenced the distribution of matter throughout the universe. Small differences, tiny irregularities, microscopic variations. Over immense spans of time, gravity amplified these differences. Galaxies formed, clusters emerged, cosmic structures developed. The largest visible patterns in existence may trace part of their history back to quantum events unimaginably small. The image is extraordinary. A fluctuation smaller than an atom helping shape galaxies billions of light years across. The tiny influencing the immense, the subtle influencing the grand. Nature seems remarkably comfortable with such relationships. A seed becomes a forest. A drop of water joins an ocean. A small beginning becomes a vast consequence. Again and again, the universe demonstrates that scale can be deceptive. Great things often arise from modest origins. Perhaps hope itself works this way. Small acts becoming larger changes. Quiet efforts becoming lasting impacts. Tiny beginnings unfolding into unexpected futures. Far beneath the surface of the earth, radioactive atoms occasionally undergo quantum decay. No one can predict the precise moment a particular atom will decay. Only probabilities can be calculated. And yet, from countless such events emerge stable patterns, reliable averages, predictable behaviors at larger scales. This is one of the recurring themes of quantum mechanics. Uncertainty at one level, stability at another. The microscopic world contains possibilities. The macroscopic world often displays remarkable regularity. Imagine standing beside the ocean. No one can predict the exact path of every droplet within a wave. Yet the tide itself remains dependable. Patterns emerge from enormous numbers. Order emerges from complexity. The universe appears skilled at transforming countless tiny uncertainties into larger forms of stability. And perhaps human life shares something of that quality. Individual moments can feel uncertain. Days may feel unpredictable. The future may remain unclear. Yet larger patterns often emerge over time. Growth, learning, healing, understanding. Life unfolds through countless small events. Only later do we recognize the shape they created. The room around you may feel almost dreamlike now. Thoughts drifting, images appearing and fading. The boundary between imagination and memory becoming softer. This is a beautiful state in which to contemplate the universe, not because it produces precise calculations, but because it encourages wonder. Wonder has always been one of humanity's most valuable tools. Before theories came wonder. Before equations came wonder. Before telescopes and laboratories and observatories came wonder. A person looking at stars and asking why. A person looking at the sea and asking how. A person looking at existence itself and asking what it means. Wonder is older than science. And science, at its best, remains one of wonder's greatest expressions. Quantum mechanics emerged because people remained curious, because they continued asking questions, because they refused to stop listening when reality offered unexpected answers. And now, those answers have revealed a universe stranger and more beautiful than anyone imagined. A universe of fields and probabilities. A universe of quantum fluctuations and starlight. A universe where particles behave like waves, where emptiness contains activity, where certainty softens into possibility. And yet somehow, despite all its strangeness, the universe remains deeply familiar. Because it is home. The same laws governing distant galaxies govern the atoms in your hands. The same quantum principles shaping stars help shape every breath you take. The cosmic and the personal are not separate stories. They are different scales of the same story. Outside, somewhere in the darkness, winds move across landscapes. Clouds drift above oceans. Moonlight touches mountains. Ancient stars continue shining. And beneath all of it, beneath every forest and city and river and sleeping creature, the quantum world continues its endless, invisible dance. Patient, silent, beautiful, as it has for billions of years, as it will long after this night has passed. And as your thoughts grow softer and slower, you may simply drift with that realization. Part of the universe, within the universe, made by the universe, listening to the universe quietly describe itself. The night is now deep and spacious, the kind of night that seems larger than usual, the kind in which distances feel farther away and familiar places feel gently transformed by darkness. A quiet street becomes mysterious. A field becomes an ocean of shadow. A distant light becomes a small star of its own. Perhaps this is one reason human beings have always been drawn to the night. Darkness simplifies the world. It removes distractions. It leaves space for reflection. And quantum mechanics, in its own way, asks for that same kind of quiet attention. Not because it is difficult, though it can be, but because it reveals itself best when approached slowly, patiently, like listening to distant waves, like watching snowfall, like sitting beside a campfire long after the conversation has faded. Tonight, let us spend some time with one of the most remarkable ideas in all of science. The notion that what we think of as empty space may actually contain enormous potential. For much of human history, emptiness seemed straightforward, a container, a backdrop, a stage upon which events occurred. But modern physics gradually revealed something more subtle. Space itself appears to possess properties, structure, activity, character. The vacuum is not merely nothing. It is a dynamic foundation from which phenomena can emerge. Imagine entering an abandoned cathedral before sunrise. The building appears empty. Voices, no movement, no congregation. And yet the emptiness feels full somehow, full of echoes, full of history, full of possibility. The vacuum of quantum physics possesses a similar quality, not empty in the ordinary sense, instead rich with underlying activity, rich with fields extending throughout existence, rich with latent potential. And perhaps this changes the way we think about absence. A quiet room is not truly empty. It contains air, memories, light, potential conversations, potential thoughts, potential dreams. Nature often hides abundance beneath appearances. Far beneath the surface of the Indian Ocean, enormous mountain ranges cross the seafloor. Long chains of peaks and valleys. Most people will never see them. Yet they exist. Hidden landscapes beneath hidden waters. Reality contains countless such layers. The visible world resting upon invisible foundations. The known world resting upon deeper mysteries. Quantum mechanics simply extends this pattern further than anyone expected. Now let us consider a question that has fascinated philosophers for centuries. Why is mathematics so effective at describing reality? Why should symbols written on paper correspond so accurately to stars, atoms, light, and matter? The question remains profound. No one possesses a complete answer, and yet the effectiveness of mathematics is undeniable. Quantum theory uses mathematical structures of extraordinary elegance. These structures generate predictions. Experiments test them. Again and again, reality responds. The agreement is astonishing. Imagine discovering an ancient musical instrument buried beneath sand. At first, it appears silent. Then someone learns how to play it, and suddenly melodies emerge. Patterns, harmonies, relationships. The instrument had always contained those possibilities. They simply awaited discovery. Mathematics often feels similar, as though certain structures already exist within reality, waiting to be noticed, waiting to be understood, waiting for curious minds to uncover them. There's something deeply beautiful about that. The universe appears intelligible, not completely, not perfectly, but enough that understanding becomes possible, enough that questions can lead somewhere, enough that wonder can become knowledge, and knowledge can become deeper wonder. The cycle continues. Elsewhere in the universe, planets circle stars beneath unfamiliar skies. Some may possess clouds unlike any on Earth. Some may have oceans of substances we rarely encounter. Some may be silent worlds of ice and stone. Others may be warm and dynamic. The possibilities stretch beyond imagination. Yet every one of those worlds, if it exists, participates in the same cosmic framework, the same quantum reality, the same fundamental principles, the same hidden architecture. There is comfort in this unity, a sense that the universe is not fragmented, not disconnected, but coherent, a single story expressed in countless forms, like one ocean creating many waves, like one wind moving through many forests, like one sky stretching above many landscapes. The room around you may feel increasingly distant now, the details of waking life growing softer, thoughts drifting like leaves on a slow river. That is perfectly welcome. This journey was never about reaching a conclusion. Quantum mechanics itself offers no final resting place. Every answer reveals new questions. Every discovery opens new horizons. Science is not a march toward the end of mystery. It is a deepening relationship with mystery. And perhaps that is exactly as it should be. Universe entirely explained might eventually become silent. A universe with endless depth remains alive with possibility. Now, let us think about the age of things. The chair in a room may be years old. A tree may be decades old. A mountain may be millions of years old. A star may shine for billions of years. Yet the particles composing these objects often possess histories far older than the structures themselves. The atoms in your body were not created recently. Many originated in ancient stars. Some have traveled through multiple generations of cosmic events. They have been part of clouds, part of oceans, part of mountains, part of living creatures. Matter is a traveler, a patient traveler, a wanderer moving through time. The same atoms appear in different arrangements, different forms, different stories, yet the underlying material persists. There is something strangely comforting about that continuity. The universe wastes very little. It transforms, recycles, rearranges. Old stars become new clouds. Old clouds become new stars. Matter moves through endless cycles, and quantum mechanics quietly governs those transformations at every stage. Far above Earth, sunlight streams through space. Each second, unimaginable numbers of photons arrive from the sun. Tiny packets of energy crossing 93 million miles of darkness. Some strike oceans, some strike forests, some strike rooftops, some strike leaves and help power photosynthesis. Without these quantum interactions, life as we know it would not exist. Every forest owes something to photons. Every ecosystem owes something to quantum processes. Every breath owes something to ancient starlight. The world around us often feels ordinary because we encounter it every day. Trees, clouds, birds, rain. Yet each depends upon layers of physical reality, so astonishing that entire libraries have been written trying to understand them. The familiar is often miraculous. We simply become accustomed to it. Perhaps wonder is partly the ability to notice what familiarity has hidden, to see mystery inside ordinary things, to recognize the extraordinary beneath the everyday. Quantum mechanics encourages exactly this kind of vision. The world remains the same, yet our understanding deepens. A glass of water becomes a collection of molecules. Those molecules become atoms. Those atoms become quantum systems. And suddenly something ordinary becomes extraordinary again. The universe regains its depth, its texture, its hidden richness. In the silence of deep space, there are photons still traveling from the earliest eras of cosmic history. Ancient light crossing unimaginable distances, a relic of times so remote that language struggles to describe them. Some of that light has already reached our instruments. It carries information from near the beginning of the observable universe, a whisper from cosmic infancy, a message preserved across billions of years. And what is perhaps most remarkable is that we can understand any of it at all. That minds made from stardust can reconstruct events from the distant past. That tiny creatures on a small planet can discover the structure of atoms and the behavior of light. Knowledge itself is extraordinary, not inevitable, not guaranteed, but achieved through patience, through curiosity, through countless generations asking questions. The night continues, the stars continue, the quantum world continues, and perhaps there is a peaceful lesson hidden within all of this. The universe is under no obligation to be simple, yet it remains understandable. The universe is under no obligation to contain beauty, yet beauty appears everywhere. The universe is under no obligation to produce conscious beings, yet here we are, listening, wondering, dreaming. For a brief moment in cosmic history, matter has become aware. For a brief moment, the universe is contemplating itself, and that moment, however small, feels precious. Outside, darkness stretches across oceans and mountains and sleeping cities. Ancient stars continue their patient burning. Invisible quantum fields continue their endless fluctuations. And somewhere between the smallest particles and the largest galaxies, consciousness drifts gently toward sleep, still surrounded by mystery, still carried by wonder, still held within the vast and quiet embrace of the cosmos. Somewhere beyond the horizon, dawn is already beginning. Not here, not yet, but somewhere on Earth, the first faint hints of morning are touching mountaintops and coastlines. The planet is always turning, always carrying different places through darkness and light. While one forest sleeps, another awakens. While one city glows beneath stars, another greets the rising sun. There is something comforting about this continuous motion, a reminder that the world is larger than any single moment. Quantum mechanics invites a similar perspective. It asks us to look beyond immediate appearances, beyond familiar scales, beyond the limits of ordinary intuition. And when we do, reality becomes vast in unexpected ways, not merely vast in size, but vast in depth, layer beneath layer, mystery beneath mystery. One of the most intriguing ideas in modern physics is that what we perceive as solid matter is, in many ways, mostly structure, mostly arrangement, mostly relationships. The atoms composing a stone are separated by enormous relative distances. The particles within those atoms occupy regions governed by probabilities. Fields extend throughout space. Interactions maintain patterns. The solidity we experience emerges from these underlying processes. Imagine an enormous cathedral built from delicate arches. From a distance, it appears immovable, permanent, solid. Yet its strength arises from relationships among countless individual pieces. Remove enough connections, and the structure changes. Matter often behaves similarly. Its stability emerges from deeper interactions. Reality is not merely made of things. It is made of relationships between things, and perhaps that idea reaches beyond physics. A forest is not simply a collection of trees. It is a network of relationships, soil and roots, water and sunlight, fungi and leaves, birds and insects. Remove the relationships and the forest ceases to be a forest. The same is true of ecosystems, communities, civilizations, even memories. Meaning often emerges from connections. The universe appears remarkably fond of interconnectedness. Far beneath the deserts of the world lie traces of vanished oceans, ancient shorelines hidden beneath sand, evidence of landscapes transformed by time. Earth itself carries memories, not conscious memories, but physical records, layers of stone preserving stories from deep history, fossils preserving moments from vanished ages. The planet remembers through structure. The cosmos does something similar. Light preserves information. Atoms preserve information. Quantum states preserve information. Reality carries traces of its past forward through time. And because of this, the universe can be studied. The past leaves footprints. The story leaves clues. The darkness around us may seem quiet, yet it contains countless histories. Every object possesses a past. Every atom possesses a journey. Every star possesses an origin. Every person is part of a chain extending backward through unimaginable stretches of time. Perhaps this is one reason astronomy feels so moving. When we look at the stars, we are not merely observing distant objects. We are witnessing history, light arriving from long ago, messages traveling across time. The night sky is filled with memories, ancient memories written in photons, and quantum mechanics helps us read them. Now let us drift toward another remarkable idea, the notion that observation in physics is not merely passive. To observe something often requires interaction. Light must scatter. Particles must interact. Information must be exchanged. Knowledge does not arrive from nowhere. There is always a connection, a relationship, an interaction. Imagine standing beside a calm lake at midnight. The water reflects the stars, perfectly still. To examine the surface closely, you may shine a light, but the light itself changes the scene. Ripples of illumination spread across the water. The act of looking becomes part of the event. Quantum measurement possesses a similar subtlety. Observation is not simply watching. Observation involves participation. The details are complex. The mathematics is precise. Yet the philosophical implications remain fascinating. We are not detached from reality. We exist within it. We learn about the universe from inside the universe. And perhaps that perspective encourages humility. The observer is not separate from the story. The observer belongs to the story, just as a wave belongs to the ocean, just as a tree belongs to the forest, just as a star belongs to the galaxy. In the silence of deep space, vast clouds of gas drift between stars. Some remain cold and dark for millions of years. Slowly, gravity gathers them. Gradually, they become denser. Eventually, new stars ignite. Light emerges from darkness. A transformation so slow that no human could witness it directly from beginning to end. And yet it happens. Patiently, without hurry. Nature rarely rushes. Stars are patient. Mountains are patient. Oceans are patient. Even quantum processes, though often unimaginably fast, participate in larger patterns, unfolding across immense timescales. The universe seems comfortable allowing things to take the time they need. Perhaps there is wisdom in that. Human beings often feel pressure to resolve everything immediately, to know, to decide, to understand. Yet many of the most meaningful processes unfold gradually. Trust develops gradually. Knowledge develops gradually. Forests develop gradually. The understanding of quantum mechanics itself developed gradually. Decades of experiments, decades of debates, decades of refinement. Understanding grows, much like a forest grows. One ring at a time, one season at a time, one generation at a time. Now let us imagine a photon, a single particle of light, born in the core of a star. Perhaps it begins its existence deep within a turbulent interior where temperatures reach millions of degrees. There it interacts countless times, absorbed, emitted, redirected. Its journey outward may take thousands or even millions of years. Eventually, it escapes into space. Now the voyage changes. The photon races across darkness at the fastest speed the universe allows. Past planets, past dust clouds, past comets and asteroids, through vast emptiness, across distances difficult to comprehend. And perhaps, after all that time, it reaches a world, a leaf, an ocean, a telescope, an eye. Its journey ends. A new event begins. Information arrives. Connection occurs. A star and an observer become linked through a tiny packet of light. There is something profoundly beautiful about that. The universe is full of journeys. The journeys of photons, the journeys of atoms, the journeys of planets, the journeys of living beings. Everything moves, everything changes, everything participates in a larger story, and quantum mechanics quietly underlies it all. Far beyond the Milky Way, galaxies drift through cosmic darkness, each containing billions of stars, each carrying its own history, its own structure, its own hidden worlds. The scale is almost overwhelming. Yet, remarkably, the same quantum principles apply there too. The same laws, the same fields, the same fundamental architecture. Reality remains coherent across astonishing distances. A single framework spanning the cosmos. This unity is one of science's most extraordinary discoveries. The universe is not a collection of unrelated fragments. It is a connected whole. Different scales, different structures, different environments, yet one underlying reality. The night deepens further. Perhaps your thoughts are becoming dreamlike. Perhaps images rise and fall behind closed eyes. Perhaps the distinction between listening and dreaming is beginning to blur. That is perfectly natural. In many ways, quantum mechanics belongs in such a state, not because it is fantasy. It is among the most successful scientific theories ever developed, but because it reminds us that reality is richer than ordinary intuition. Reality exceeds expectation. Reality contains depths we rarely notice. The world is stranger than it appears, and also gentler. The stars do not demand understanding. The oceans do not demand certainty. The universe simply continues, patiently unfolding, patiently revealing itself, one discovery at a time, one generation at a time, one curious mind at a time. Outside, somewhere far away, waves move across a sleeping sea. Elsewhere, snow falls silently through moonlit forests. Elsewhere, desert winds shape ancient dunes. Elsewhere, starlight crosses distances so vast that language begins to fail. And beneath all of it, beneath every landscape and every dream and every sleeping city, quantum fields continue their endless fluctuations. Particles appear as ripples. Probabilities become outcomes. The hidden machinery of existence continues its work. Silent, invisible, ancient. A vast universe building stars and oceans and living beings from the same elegant foundations. And as the boundary between waking and sleep grows softer, perhaps the deepest lesson of quantum mechanics is not merely that reality is strange. Perhaps it is that reality remains full of wonder, a wonder that survives explanation, a wonder that grows with understanding, a wonder woven into every atom and every star, a wonder that has been waiting patiently for billions of years. And tonight, in the quiet darkness, it continues waiting. Calm, endless, beautiful.